Okay, welcome back. Okay, bear with me a second while I get organized. I'm always trying to get organized here, and but sometimes the funny thing is that I put the camera upright, and then then I can't get the camera to begin to start to record. I'm there tapping like nobody's business, and the damn thing still wouldn't start. So I've decided to start it before I actually get onto it. Okay, right. Right, what I want to look at is good morning, good morning. DC machines, okay? And that's what I want to look at today. Now you find also that I've placed some questions in regards to DC machines, which I hope you'll find useful, okay? Now, principle of operation of a DC machine. All motors and generators make use of two basic principles. When two poles of a magnet are brought close together, then there will be either a repulsion force or an attraction force. When current flows in a conductor, a magnetic field is created around that conductor. Okay, and that is the simple principles by which most motors operate on. Okay, we have to say most because with new advancements in technology, with new ideas of looking in outer space, and with different principle of operations, we are looking at different type of motors which will probably be coming onto the market, or if not already on the market, that will give us a different perspective of operation. Okay, so it's worthwhile keeping your mind open and looking to do additional research in addition to what I have provided you with here. Okay, and here you can see magnetic fields, okay, north, south, and that's our field rotation, okay, from north to south, okay. And current flowing in conductor, you can see the current flowing. Now this indicates that the current is coming towards you because it's a dot, okay, okay. And you can see here current flowing into conductor, current flowing away from you because it is across, okay. So we know that the current can flow in either direction, either towards you or away from you, depending on whether or not you have reversed the direction of the motor in regards to the cabling and the supply cable that has come to your motor, okay? Magnetic field in a coil. When a current is passed through a coil, a magnetic field is generated, and this is our coil. We would normally look at this as calling it a solenoid because it allows us to, when magnetized, to close switches or open switches depending on the use to which the solenoid has been put to, okay? The armature windings start and finish at a point on the armature called the commutator, okay? And that is our commutator here. Let me just see if I can make this a bit bigger. Hang on, let me see if I can go into it. Okay, let's just, cooling fan, shaft, okay, armature windings, okay, bearings, commutator, laminated iron core, okay. Okay. Now brushes. Okay, just let me make sure that it is in view. The final part of the machine is the brushes. The brushes on a DC machine are made up of carbon. Carbon has a number of qualities that make it ideal for this purpose. It is very soft. It is a conductor. It self-lubricates. Okay. Now here you have your brushes. Okay. Now the brushes here are adjustable. They are self-adjusting. They're loaded onto a spring within the brush carrier, and then they are secured in position against the commutator, which holds it in position against the comb. And here you can see your comb. Let me just go in a bit closer if I can. You can see your brush here, okay, and it's in the housing which is secured. And here your commutator. Let me step back a little bit. Here's your commutator, and here are the brushes faced up against the commutator being fixed back into position. Okay. Now, the brushes provide one of two functions. For a DC generator, the brushes act to tap the supply off the armature. The brushes act as conductors and lubricators. For a DC motor, the brushes act to deliver current to the armature, where again the brushes act as a conductor and lubricator. Okay. Now, commutation. Let me just see if I can go into it to that, making it more visible. Okay, I think we'll leave that there for now. Let's get back to you. Okay. And yeah, pull you up a little bit, and a little bit, you bit about you. Okay. Okay, yeah, I think I've got it. I think. Commutation. A commutator is made up of a series of segments, which are conductors separated by thin pieces of an insulator, such as mica. There are other forms of insulators, such as paper, but we won't deal with that at this point in time. Insulating material, okay, carbon brush, the shaft, okay, commutator segments, okay, and armature windings are connected through the copper segments, okay, and you have many copper segments. This is just one, this is just taken as one piece to show you what the action and function is of it, okay. DC generator. Now let me see if this gives me any kind of controls on here. Let me just play with this for a moment. Right, I'm just going to have a little play with this, okay? So just bear with me. I have no idea what it's going to do. Controls, what does that do? That holds it, okay? Let me see if I can. See, you can, I'm going back. And you can see where sorry about that. Sorry about that. It's okay. These things happens. And let me go back to where it was. Just recapping. It's okay. Just recapping. Okay. Go back to playing again with this. Again here. Let me just see what I'm going to do with it. Okay. Now this waveform here. Can you see it? Can you see it? This waveform here is a half waveform, okay? It's not rectified, it's a half waveform. It's simply converting the negative half cycle of the AC waveform into a positive half cycle. So you have a number of cycles here. Now to get this smooth and continuous, you will need to apply a capacitor in the circuit, which will give you a smoothing effect and a more consistent DC output. Now you can see here, simply by tapping that, I am moving that, inching it basically. And you can see here that each of this coil is connected to, well, part of the commutator. Okay, and let me go to play. Okay, and there you are. You have positive and negative because you need to create a current flow, and that is your current flow output. Here is the waveform that's being produced by this single coil of copper wire. Okay. I'm just trying to figure out how I finish. Okay, that could be it. Thank you, I think. Bear with me for a second. Let me just escape and come out of that. I just need to make sure that I've got all my bits and pieces. Yes, it is. Okay. Okay, thank you for your time. I hope you have found this useful. Okay. Okay, thank you. Have a good day. Bye-bye.